Good afternoon.
Good afternoon. Can we start? I think there will be less number of students joining.
Only one has joined, madam. What will do? Only one student is there.
What should I do?
Give me 2 minutes, madam. I'll call L2s whether they'll join or not. Hmm? Amanya, Amanya. Madam, what we'll do, madam? Only one student is there. I don't think they'll join.
Okay, two are there. Who's Acha?
Only one. Shweta is our L2. Oh, yeah.
Okay, so
One more joined. One more joins.
we'll wait for some more minutes and
Okay.
then we'll do one session of some
Okay.
time and then we'll leave it. Okay.
Okay, madam. Okay.
Okay, I can just start. Let us see how it goes, right? And
Yes,
the
yes,
students
ma'am.
mine or not. And if they're not joining, maybe within 1 hour or something, you can just ask your officials when if we can close it. Just
Okay.
enable the sharing.
One second. It is shared.
ಹುಡುಗರಿದ್ರು ನಾವು ಇಲ್ಲಿ.
So those who have joined, thank you for joining. In the last session, if you remember, we were doing about how AI can be used in security. And we saw that we can have kind of three approach, which is adapt, action, and all. Just give me 2 seconds, please. Sorry about it. So yesterday we were looking at how we are using AI or machine learning, basically the supervised and unsupervised learning technique to provide the security or prevent the security. So we have three mechanisms. Yesterday we discussed about that, which was adapt, action, and response. And in that we understood that how a company can adapt a policy and how they can create an action to prevent these kinds of attacks. In case if the attack happened, what kind of response they should have. So when we are talking about this, even I told about if you remember, we talk about 6 disciplines which should be there when you are making a solution with integrated AI for the security, which is about these, which we discussed. Not all disciplines are necessary. So this is the one which we were discussing, adapt. So now we are going to go forward with the other input. We also discussed about the traditional approach of security and the new approach about intelligent agent. So now, as I was telling you about end-to-end security in the last class there, today the companies are looking forward for end-to-end solution, like end-to-end encryption in WhatsApp chat. Similarly, end-to-end security framework is something which the organization is looking at. And they want a kind of a security process or policies or control which can achieve these objective of end-to-end security. That means even a data which is non-confidential in nature should be secured from unauthorized access, right? It should also be any kind of security to any kind of data. The organization doesn't want to take any kind of risk, even if it comes to non-confidential data also. I give you example of Sony, that how they have not provided the security, because initially what used to happen, students, that the organization used to categorize the information and data into more secure, more confidential, non-sensitive, sensitive data, and set up the priority. And then accordingly, they used to provide security. So like even the law, the IT Act 2000, which is applicable in India, suggests that the company should be very strict when it comes to applying security to financial data, the financial transactions. But when it comes to personal data, when it comes to any other data apart from that, non-financial data, the companies in India are not liable to do that. So the companies fail to do this. But then many companies are finding it very difficult that they're not able to protect their data, they're not able to protect their intellectual assets, they're not able to protect their, any processes, which is in the form of application on cloud or anything. Okay, so all these things we've already discussed. Okay. Okay, so we have already discussed this. I'll just go ahead. Okay. So now let's talk about how a particular organization prevent the attack on their intellectual assets. Okay, the intellectual property, the confidential data. So as a security professional, if you are trying to develop a solution using AI, it is your job to ensure that the information and assets of your organization are protected and secure. And in order to do so, you depend on some crucial information. The information that is buried in the petabytes of logs, network packets, files generated every second by almost every device or software on your computer network. So regardless of how much you despise or how you use this is a very Herculean task. It is essential for you to shift through these data to prevent the next potential breach. But the challenge is that the amount of data which is generated in the organization is enormous. It is never ending. It has a complex interrelationship among themselves. So when you monitor these data 24/7, you do it by yourself. But relying on number of different tools, like, for example, a sign of suspicious activities, and these tools, using a tool, if you try to come with an alert on suspicious activities, then you have to depend on those tools. These tools may have certain limitations. It can be a limitation in the source code. It can be a rule-based approach. It can be the data which is coming is not classified properly. So let's take an example. Just a typical homeowner who worries about, a potential threat by a bubble. Suppose you are going for a vacation and you close your, house, and so you close your house and you make sure that your all belongings, especially the precious belonging like jewelry or anything, is basically secured on it. Okay. So similarly, the problem comes when, so what happens when you are taking an example that you are trying to avoid intrusion by burglar. So you use a lot of method. You will lock the door. You may have a security at the gate. You may have cameras installed. You can monitor your house 24/7. It's not possible to do that, but still you do that. And security professionals you can appoint because you want to prevent the attacker to your thing. So similarly, a company also want to worry about, or they may also have a concern regarding the intrusion by attacker into their network. And the goal is that they should allow only a desirable traffic, authorized traffic to their network. They should be able to identify any unauthorized request or any unauthorized inflow and outflow of the information from their server and stop it. So the known solution in the industry for this problem is deploy an intrusion detection system, which is called IDS. Okay. So when we say IDS is a very common term which is used in cybersecurity. And there are two types of IDS: network intrusion detection system that monitor the traffic pattern for the entire network activity, and the host intrusion detection system. So I said there are two types of the IDS. One is network intrusion detection system, which will monitor the incoming and outgoing traffic pattern. in the entire network activity. Then the second one is called the host intrusion detection system, which will monitor a particular machine. So your workstation, maybe it can be a server for any kind of abnormal pattern, any kind of something which is suspicious in nature. So IDS is something which is companies are using. It has AI tool integrated and it looks for, it scans the system, it scans the network packets, it scans the log data, it looks for the signature and it try to identify a pattern and match a signature which is known to be suspicious. So if IDS is failed, if IDS sometimes fails to find the signatures, or if it does not understand or catch an intrusion, that means unauthorized intrusion, if it get undetected, so sometime it may happen. So that's the reason why in a traditional IDS, this kind of challenges are happening, where they're not able to catch the intrusion on time. And by the time they catch, the damage is already done. They are unable to identify these certain kinds of attack because the attackers and the traffic seems to be with matching the normal kind of a pattern. So it's very difficult. So what happens? We need to use AI here to identify a slight difference in the pattern, whether it's in a log file, network log file, it is in the traffic, or it is in some kind of a network activities. So this kind of thing happens. Otherwise, what happens? Most of the organization from time to time, faces this problem of denial of services, DDoS attack, hacking, and all those kinds of things keeps on happening if the intrusion detection system doesn't have AI integrated into it. So these features, what AI does, it adds certain features like some protocols which are used like IP addresses. It may also have certain kind of identification used with the help of packet containing strips or knots, whether it is matching with the usual scripts or not. The algorithm which is scanned and try to find out if it is matching or if there's a slight differences or deviation. So AI is searching for a difference, a slightest difference, which a traditional IDS cannot detect. And it can identify. And that is basically called in AI, when you build a cybersecurity solution, called predictor model. And this predictor model work behind the scene. And what they are, how do you train them? You train them by giving a lot of training data, right? You train the model using features to detect the abnormalities, to detect the intrusions. You then deploy the trained predictor model and it basically monitor the incoming logs, traffic data continuously, which passes through this predicting model. And immediately, if there is a deviation, it can immediately identify that and it can try to prevent it. So those kinds, because if you remember last session, I was telling, it's not about detecting. It also, the AI should suggest and should enable the damage which can be caused once it is detected. You have detected the intrusion, but after that, what should be the action which should be taken? That also is something which AI does. So now, students, it is not necessary that you need to be a security professional or you need to be an HR person or a top executive, which is concerned about or which has a responsibility to stop the leakage of confidential data, which is very important for your organization. But today it is being said in the organization that all the employees are responsible for the security and protection of the data. So the organizations are basically trying to train their employee that how they should not intentionally or accidentally send confidential data to undesired recipient. And this, because this may, sometime it may happen that by mistake you have done this. Somebody might have fooled you. So some common examples are, sometimes we say that most of the kind of big threat to the security of the data and the IT infrastructure is from inside. And we say it is insider threat. And when we say it is an insider threat, that means what? These are some disgruntled employee who are intentionally emailing upcoming merger documents. Sometimes, this example, one of the examples, there was some case study where some disgruntled employee who got a news about company, resizing, and are asking certain employees to leave the organization, and they were giving them some 3 month salary. And so some of them were really angry and upset, and intentionally they emailed the upcoming merger documents because the company was going for a merger. And when the company was going for a merger, the merged company didn't want so many employees. So that's the reason certain employees sense that they're going to lose the job. So in order to, because they were thinking that we have been, hurt by the company, we should also do some damage to the company before we are thrown out of the company. So they intentionally email the upcoming merger documents, which they had access to an external analyst. And they also told accidentally they uploaded a business file to the personal cloud folders, their own personal cloud folder, to be misused later. Now, how do you solve this problem when internal people only insider, when the security becomes a big threat because the insiders are involved in that? To solve this problem, you have to deploy a data loss prevention solution, which is called DLP solution. So what DLP does, okay, so the DLP, these are all technology which is used for the AI professional to develop the security solution. So DLP solution look for a sign of confidential data crossing the trust boundary. For example, if the employee is angry and he want to do something like that, he want to pass on some confidential data to his own personal folder in the cloud, or maybe to somebody else. So you should have this kind of detection system, because normally what happens, the data infusion system or IDS basically look for external data which is coming to the server and check for any kind of unauthorized action or unauthorized access. But what if it is going from inside, which is trustable source? So the trustable source from where the data has been transferred to the destination where it is transferred, we have to employ some AI technology, because we can't just go and catch hold of an employee and say that we are suspicious that you're going to do this. So you need to have certain kinds of, you have to catch them red-handed. Then only they will, you can, imply certain punishment on them. So if it is suspected any activity, what it does it before, it will not allow that particular information to be transmitted. And also at the same time, notify the important people, maybe the manager, maybe the IT department about this. So DLP is an approach where you can prevent the insider or the employee to send data by accident or by intentionally to somebody or to themselves. So traditional, DLP is not a new technology, students. It is basically a traditional DLP software is also there. Today the DLP uses AI. The traditional DLP software used text matching approach against a set of predetermined word or phrases. Like for example, if you have Gmail and you are sending and you are writing certain words like bomb or explode or fire or something like that, those are some catchy words which are suspicious in nature. You all know that your all email, Gmail, whatever you are using or whatever search you are doing on the search engine, everything is monitored through the software. So we say big brother, watching you. So that big brother is NSA, National Surveillance Agency in the America. And they ask all the company to surrender the data, even the Google to surrender all Gmail data and all. They don't do any harm to you. But in case, you never know that if you're searching for something like how to create a bomb on Google search, it flags those, the word will flag and it will become suspicious, and the government or the related people, the surveillance people will start monitoring your activities unknowingly. They'll try to find out whether you are seriously trying to do some crime or not. So these are called text matching approach. This was a traditional approach. But to get it right is a real hard problem, because now people have become very, very, smart. They know that how the DLP work. So they won't use those words which will flag trigger that there is some suspicious activity from the employee side. So it's, wow, what is happening now? If you set the DLP threshold too high, I'll just give you some example before I explain this. So, for example, certainly the email which comes from the CEO to a top customer. Suppose if it is good, somebody sends a email from the CEO to a customer, and CEO, you can't do anything. Even if you monitor his mail, you can't block. Even if it is text matching with some suspicious word, you can block, because that you cannot do. So you have to set the threshold to low the confidential data start appearing in personal folder of your employee Dropbox. So let's take an example. If you see on the slide, there are two different employees at two different departments of medical facilities, and they have sent out two separate messages to the external vendor. And the message from the first employee contained personal health record. Okay. And health record are governed by HIPAA law in United States. So it must be handled under a very stringent security and privacy policy. It should not be available to everybody, only to the person and the doctor. And the message, if you see in the second one, the second employee does not contain any personal information. Here you have a report of somebody's blood culture and stool. And the report, what it has detected, is also written. Whereas in the second report, it is trying to give some instruction where there's no personal information. It is a request just to place an order for office item. So if an employee of the organization were to read both these messages, a human being read this, they will instantly be able to determine that one is more sensitive than the other. That means the first one should not be shown to everybody. It is sensitive in nature, but the second one no. So when we look at traditional DLP solution, which is based on text matching, it will flag the sensitive data based on keywords, which will be challenged. Now in this, the explanation is what? Human have the context. So there is a context. So you can see here, these are the keywords, culture, stool. Here also the word is stool and culture. But the context of these two mails are different. So because of the context, you can easily identify the first mail is little confidential, but the second one is not. But in traditional DLP, both are confidential because it uses certain words which are basically matching with the most challenging or most, the word which is sensitive or which is suspicious in nature in that dictionary. So what I'm trying to tell is that human have context, while traditional DLP, right, doesn't have. So how do we add context so that the DLP may identify the difference and can categorize not based on text matching, but can determine the spot with the help of context like a human being. So let's see how AI-powered DLP is trained and then used to identify sensitive data based on context, not on word. Yesterday also I was telling you this, that the AI doesn't look at the word, and if the words are matched, in both the cases, culture and stool is a very suspicious word. But both have a different context. And if you read as a human being, you may find that the first one is sensitive, second one is not. So the context is something which machine learning model is now doing. So how do we do that? We feed multiple set of training data into machine learning model. And the first training set data include words, okay? And those words and phrases that must be protected, such as intellectual property, technical information, personal information. And the second set includes unprotected data that must be ignored, keeping in mind that the word and the phrase that may be unprotected in one line of business and maybe another line of business, it is protected. And lastly, the model is fed with the information about semantic relationship among the words using a technique called word embedding. And the model is then trained using variety of learning algorithms. So once the trained model is deployed on incoming new documents, it is able to recognize the relation between the words and understand the context just like human being. So AI-based DLP finally assign a sensitivity level after the result outcome of that AI-based DLP. Once it goes through those messages and find out those protected and unprotected word, and with semantic relationship, it can understand the context. And the outcome is that it will apply the sensitivity level, whether the data is sensitive, more sensitive, personal, or confidential, all those kinds of decision. And then based on that, it may block the transmission if it is not supposed to go to that particular destination. So this is how the machine learning, is replacing the traditional approach and understanding, making the computer understand the context, depending on the context, understand the sensitivity of the data, especially in the industry like bank, healthcare, okay, IT industries, and okay. You see how many of them. It's only 5. Okay. So now we will talk about problem of precision and accuracy. So when we say AI, what is the precision level? What is the accuracy? Is it 100%, 78%, 80%? The precision and accuracy depends on the problem of scale. Okay. For example, a software developer was just informed that the code he or she wrote has a security vulnerability, such as SQL injection, cross-site scripting. These are certain words which we use in this security terminologies. So how trustworthy is that information? Okay. So is the static code scanners really pointing to the real issues? Or it's a false positive and false negative report? So security operation team that is monitoring the network discovers a set of event in the log file that may point out to potential breach. But how sure and what is accuracy of that security analyst? Is it really an attack or a normal activity that the analyst just hasn't seen before? Or maybe he is very extremely cautious, and because, like, for example, CEO sending some mail to a customer and it has certain protected word. So acting on the false positive not only drain the organizational resources, but also distract team from real issues. Sometimes what happens, the cyber criminals are very smart. They want to divert. Have you seen in many movies? They also work exactly similarly. That sometimes the criminal, what they do is, in order to distract the professional police personals, they deliberately place some kind of a clue or a hint so that it points out at something, and the entire police department work on based on that team. So they divert the attention of the team and then they attack. So similarly here, the cyber criminals are no different. They also do that to distract the security team from real issues. And behind the scene, they come up and they attack. This has happened many, many times. Okay. So let's take some example. Let's take the example of what is the need of accuracy and precision. By looking into the phishing mail, you all know what is phishing. So phishing is a type of social engineering attack where an attacker presents itself as a trusted entity, like a bank, and trick the people by giving certain. You may get certain phishing mail from a bank which looks like a real bank mail, and they ask you to click on certain data to verify, and you trust the fact. You click on the link, you go to a clone site of the bank, and you take certain action, and your money is siphoned off. So this is, and so how do you do that? For example, an attacker gains the trust of a person here and then lead him or her to share their personal information in phishing. It happens like they gain your trust, like you've seen the web series called Jamtara. They used to gain your trust and they used to ask you, maybe they will say there's an incentive, there's a reward, and you get, because influenced by those talks. And you provide your personal information like your bank account detail, your password on a fake website. So for enterprises, phishing attacks are extremely dangerous. You are looking at your personal level. Look at the level which the organizations are facing. They also get phishing attacks, and very dangerous because such attack uses the normal channel of communication, such as email or messenger app. Traditional tool and security controls such as firewall, your IDS, intrusion detection systems, are blind to such attack. They will find a loophole and try to exploit that loophole. So let's say an unsuspecting person receive an email announcing that their personal information has been the part of security breach. Now, to an untrained eye, the email looked very credible. Furthermore, the email invites the subject to enroll for a free identity protection monitoring. And what's not obvious is that URL of the enrollment page is going to be a fake website, which spun up by the attacker to capture the subject personal information. So the irony is that the subject's personal data is compromised to begin with. So here are two websites which is shown on the slide. One of them is real, the other one is fake. So can you spot the fake one? The design of the website is almost similar. They are identical. But if you see the URL, there is a slight change in the one word, one letter, which is here you can see California, and here the I is missing. But when you look at and when you go to the site, we normally can't make out unless we are very observant. So if you're not careful, which we most of the time are not, because we trust the kind of a mail which we have, we trust that it has come from a credible source. So it's very easy to miss out on those small kind of differences. So you just look at the site which is same because you've gone to the site design and everything is same. The only difference is the URL. So as a result, you trust and you share your personal information on this fake site. The traditional approach is to catch the fake website used for phishing attack is to compare the URL against the block list. Like you may have a complete block list which is fed into the IDS system, and through that, if in that block list that particular fake site name or the site whose fake site is already existing, that will come. And the block list is usually maintained using web crawlers. Not manually it is maintained, but usually it is done by the web crawlers. Now, the web crawlers so the problem is the block list can get outdated quickly and we can lead to some statistical error, a false positive error. The false positive error means blocking a genuine website because the phishing detection algorithm failed to correctly classify it as a fake website or genuine website. So imagine the inconvenience and the potential loss of business if you block a genuine website. A false negative error, okay? So a false negative error, what it does is, it also failed to detect the fraud website. So what if an attacker just spun up a brand new phishing site, which is not updated in the block list? So how do you come up with a solution that is intelligent enough to analyze a website on many different dimensions and characterize it correctly with accuracy? So going back to the phishing example, let's look at the feature of website that can be used to building a trained model. Okay, so what are the features which are basically used to identify a phishing website? And a website that is genuine and trustworthy is going to exhibit a pattern of attribute among the 3 domains. Okay, for example, its reputation in the form of incoming links. Okay, certificate provider, user record, TLS certificate, and rank. Okay. Similarly, such a website will also exhibit a pattern in its network characteristic, okay, and its site content. Of course, you would not know to begin with which of these features correlate with the genuineness of the website. But with the experiment with the group of feature, you can arrive and train the model that is accurate enough for the phishing use case. And when a user tries to access a website, before the content of the website is returned to the browser, the web server query the phishing classifier, whether the request of the URL is permitted. If approved by the classifier, the user is shown the content. Otherwise, user is notified that the content of the websites are malicious. So this is how today AI is used to, the machine learning algorithm is trained with these features instead of training them with the kind of block size list. And this training data help the machines, helps the system or the software to classify the phishing sites and non-phishing sites. I hope you have understood this. Now, the next thing is the problem of speed, because it's very important how fast you can act on the threat. You already identified there's a threat which has entered into your system. What is the speed at which the security team can save their entire data from being misused? So if the security team are able to shift through the massive amount of log and even accurate enough to find the issues, or by the time they are trying to find out what kind of attack it is and find the solution for it, it might be very late. Okay, so an attacker, by the time you're able to detect a threat in your environment, an attacker was able to retrieve the personal data from your organization server. And they were able to, most of the time, they will post it on the dark web. Okay, so not only do the security team have to be right every time, but they also have to act very fast. And today's adversaries, they should be aware of the capabilities of the security tools and how to avoid getting them. They take advantage of the noisy network environment, these attackers. And these security team need to have patience, persistence. They have to act in stealth environment. Do not expect to see how big bang until after. They should not get panicked. They should not blow the trumpet so that everybody knows about it. So how can artificial intelligence help you in catching such security threat that act almost like a terrorist sleeper cells? So AI does not directly improve your responsiveness after an incident has occurred, but it prepares you to be a step ahead of the incident in order to prevent it. So what it does, it predicts a future incident and act beforehand. How? By analyzing the behavior, the event ongoing in your environment. You can predict with reasonable accuracy whether the circumstances is pointing toward an attack. So let's look at an example. Okay. How you can use predictive analytics to predict risky logins and take pro action. Any request to access network resource must go through authentication of access credential, such as username and password. You all know that. But the fact that the credentials are validated does not necessarily mean that your requester is a truly person who we think he or she is. So is it possible that the attacker has compromised the identity of an unsuspecting user to effectively attack? How can you tell? So we use something called a predictive model that learn from the characteristic of previous logins by the organizational users, and let the predictive model, they build a pattern of what it thinks the business is. The logins are usually, what is a usual pattern? So some example of those characteristics where I've listed here is IP address of the user, their geolocation, even Amazon and Flipkart is doing that nowadays, usual days and times of login, and so on. And for each new authentication attempt from new devices, the model estimates the probability of it being a suspicious or risky login. So it takes a kind of a taking into account location, time, other factor that is supplied with the logging attempt. For example, if a user login in usually from a window operating system, okay, let's take an example, and window machines, window operating system, and the place is New York, and they log between 7 a.m. to 7 p.m. Eastern, and the next login happens to be from other operating system Linux, and it's a machine from Portugal, and the same login credential. So that means it's risky. This is a very simple model, but we can train the AI model can with this capability to find the pattern across many dimensions of credentials. Okay, and where we can use also rule-based approach. Okay. Just leave this. So what are the kind of categories of machine learning algorithm that we are using in this security professionals are using? So the discipline of learning is now one of the capability that is exhibited by AI system, and what you should be learning in order to become a AI expert in cybersecurity environment is one is machine learning, which is a type of learning that uses statistical technique model to perform a task without performing, which is unsupervised or reinforcement learning. Then deep learning, on the other hand, which is a type of machine learning which uses layering of manual algorithm. It tries to mimic the way neural network of our brain function. So when you build an AI-based security solution, you have many machine learning algorithm at your disposal. Okay. So algorithm you find up choosing depend on two micro factors. What kind of training data is available to you? What type of security problem you are facing and trying to solve? And if you study your organization vulnerability, like your log files, packet tray, user access records, you discover two types of sample data. First, the type of data whose characteristic you fully understand, like login credentials and all. In other words, you already know that the data in the hand is will have certain kinds of regular characteristics. You can identify that in order to be a genuine data. And a website that you know is a fraudulent, which is phishing attack, for example, may have certain characteristics which you can identify and train the AI model on that. So that's how you can do all these kinds of things basically. And as you know that the machine learning has three types of classification. One is supervised, unsupervised, and reinforcement. But in this case, we are using both. The supervised learning, which is training the AI model with labeled data, and it uses regression and classification method. Whereas in unsupervised learning, use input data which is not labeled, and use clustering and generative method. Okay, so these are there. So now,
it's all the rage these days.
Let's see how machine learning is used in AI.
It's all the rage these days. Companies touting machine learning this, machine learning that. Vendors promising a cure-all for every IT challenge. The hype is getting pretty thick. So what exactly is machine learning? Traditionally, computers solve problems through programs or instructions given to them by a human. Machine learning just means the computer can figure out a solution without being specifically programmed. These machines have the ability to continuously learn by looking at data and finding patterns. And they do this much faster than a human could. Let's look at two key terms in machine learning: classifiers and algorithms. Classifiers are the workhorse of machine learning that categorize observations, while algorithms are the techniques that organize and orient classifiers. Often, machine learning requires training with sets of correct question and answer pairs that lets both the classifier and the algorithms do great work. Let's look at an example to see how it works. Classifiers analyze specific data patterns, not actual noses or eyes. And with enough training, they can pick your photo out of millions of options. So how do we use machine learning in security? Envision an analytics pipeline that uses many hundreds of machine learning classifiers and algorithms all working together, analyzing millions of internal and external data points and events. The pipeline identifies and separates suspected malicious activity from the normal. It's then organized into specific events and then combined with actionable context for security teams. And it does all this at machine speed. Pretty amazing, right? But machine learning isn't perfect. While rare, it can miss a threat or block a legitimate file. When pressed to explain decisions, it often shares only math logic, which is not helpful in a security investigation. And it requires retraining to account for real-world changes. So how does Cisco use it? We never use it in isolation, but alongside other techniques to detect malware in encrypted traffic, to find insider threats, to keep people safe when browsing by predicting bad neighborhoods online, to protect data in the cloud by uncovering suspicious user behavior, and many other applications. As a leader in machine learning, Cisco is using it for more effective security. Take a deeper dive into machine learning and Cisco security products at cisco.com/go/stealthwatch.
Okay. So this was a Cisco. So now let's also try to understand a very common need in security space to predict how do the predictor model work with AI. How before attack happens, the AI predict the event or the attack. So this is something which will take some two examples. And the predictor model has a goal to predict the event, basically the threat or the attack. And here, our goal in this example is to predict the count of IoT device deployed in a field that may be tampered with during an attack. So sometime when attack happens, related technologies are tampered. So if you're using an IoT device, and let's say these IoT devices are tampered. So you want to build a machine learning model by using a captured network packet, okay? And that captured network packet and sensor data emitted from those devices over a period of time. In the second example, you have an ongoing distributed denial of services, okay? So we are taking one example where we have an attacker is going to tamper the IoT device and the IoT devices will send the incorrect data, okay? The kind of data which will emit from these, get it input into the device will be wrong. In the second example, you have ongoing distributed denial of service attack, DDoS, in your network, and you want to predict the short-term intensity of an impact of these attacks. So you do have the access to ICMP, SIM, and the other network packets to create your label data. So such prediction problem fall under the broader category of so-called regression problem. So by identifying your problem as regression problem, you automatically narrow down the list of algorithms that you must choose from. So some of the commonly used algorithms for solving regression problem are linear regression. You should be well versed with this. If you are using an machine algorithm, you need to know all these quantitative technologies very elaborately. So some of the commonly used is the regression, the linear regression, support vector regression, random forest, decision tree. You should be well versed with all these things. Regression, ANN, artificial neural network, and then a regression algorithm attempt to build a mapping functions, right, between the input variable and output variable. And of all the regression algorithm, linear regression is probably one of the simplest mode of machine learning that is both very easy to apply and understand, and most of the commonly used algorithm. So if in its simplest form, the algorithm generate a model that is simple as linear equation between the output variable y and the input variable x, and predict the value of y, just plugging in the new value of x, it can do that. So other models such as support vector regression allow you to build more complex model around the curve rather than the straight line, rather than a linear equation, okay? So those can be used in this. Now, how can you do the classification? How you want to segregate event into known category, such as like whether a website is fraud or a genuine. So bad means fraud and good means genuine. An email that you have received is a phishing email or a genuine email from customers, whether the login attempt is from expected users or from the attacker. Such problem falls into broad category of so-called classification problem. So generally speaking, classification is the process of segregating new data into previously known categories. Now, both regression and classification problem can be solved with supervised learning because they both require prior knowledge. So in other words, it is labeled data, task data. It performs certain tasks. In the regression problem, the output of the model is numeric variable, while in the classification problem, the output is categorical variables. So you will use regression algorithm to solve a problem such as predicting the number of user accounts, okay? Number of compromised accounts. On the other hand, you will use a classification algorithm to determine whether the source codes contain a cross-site scripting. To solve a classification problem, you choose one of the classified algorithm that map data into categories. So some of the algorithms that are logistic regressions, k-near neighbors, support vector machines, naive Bayes. So many algorithms you can choose from. So this is how the security professionals are doing like that. So let's see one video.
In our previous video, we explored the core differences between supervised and unsupervised machine learning. Now let's dive deeper into supervised learning and examine two different methods, classification and regression, and their applications within product design. Classification predicts qualitative targets using labeled data to identify something that the user specifies. For example, as an engineer is working with a CAD model of a car, they can train an algorithm using example parts to identify groups of individual pieces, such as the windows, body panels, tires, and wheels of a new assembly.
My voice is not audible.
So till now we've understood that how we AI model draw an insight from the data. And without data, the training is not possible, whether it's a supervised or unsupervised learning using machine learning. So what it does, it try to, in unsupervised learning, it try to find a pattern in the incoming internet traffic to your web server and distinguish the user from bots. Most of the time you might have seen that it says, prove that you're not a robot. Okay. So you don't have of course, we don't have a label data to train the model always. So you build an unsupervised learning model where you don't label the data. And you analyze the log and find interesting pattern and cluster the similar kind of data into one cluster. And such problem falls into the category of clustering problem. Why clustering? Because most of the time the data is not labeled. You don't recognize what kind of data and you can't put. So supervised learning is not possible here. So in unsupervised learning, the cluster algorithm group or cluster data with similar characteristics. Okay. So classification problem is it same like clustering? So no. For classification, the data which can be classified and labeled use a supervised machine learning method. The data which cannot be classified use clustering method based on characteristic of the data, similar characteristic and pattern. Okay. So in security environment classification, the categories are previously known as fraud versus genuine. Okay. And the supplied versus label training data. On the other hand, in the clustering, there is no preconceived notion about the grouping. The clustering algorithm creates the group without any oversight, without any perception. So no wondering classification is supervised learning, while clustering is unsupervised, which I just told you. So you can break a clustering problem into two uses case: pattern recognition, okay, and anomaly detection. In pattern recognition problem, the goal of the underlying machine learning algorithm is to discover groups with similar characteristics. And some of the example of pattern recognition algorithm are k-means, self-organizing map. Okay, these are the example. On the other hand, in the anomaly detection problem, the goal of the underlying algorithm is to identify the natural pattern inherent in the data and then discover the deviation from the natural pattern. So let's say you have a Docker-based container environment, okay? And with many containers active and running. And by the way, the container is a form of virtualization, the virtual machines. Maybe, I don't know if you've learned about cloud computing in that. So in order to detect suspicious program executions or a suspicious network activity, you build an unsupervised anomaly decision model to access the file, network traffic, process the back of your input data, cluster those data, input data which are not labeled or not classified into your system as suspicious data. Still unsupervised learning will take those data and try to detect a pattern which looks similar to suspicious data. That's called clustering. Okay. So now let's see this.
In our previous video, we looked at classification and regression, two key types of supervised machine learning. In this final video in our series, let's explore two methods of unsupervised machine learning: clustering and anomaly detection. Clustering is a technique that involves the grouping of unlabeled data to identify patterns and display information that's similar. Imagine an automotive engineer browsing through a catalog of reinforced brackets. By clustering the parts based on performance reliability, the engineer can weight up available options and ultimately design a safer vehicle. More broadly, self-organizing groups created from clustering can frequently replace formally manual processes performed by humans, saving time and resources. Another type of unsupervised learning is anomaly detection. This is a technique that identifies rare events or outliers in data that are statistically different from the rest of the data. For example, real-time data from jet engines can be used to monitor the health of the equipment and detect if certain in our
Okay. So I'm not going to go further detail into technical issues because only 2 students are there. So I'm just going to skip this. And we are just going to look into some AI generated fake images um, and the video which resembles actual person. So how do you detect whether the person, the audio, text, or the deep fake videos can, how you can find out that? So this is where I think I may end. But before ending the session, I will tell you that the AI is not a perfect solution, but it has certain drawbacks. So let's look into the 3 ways AI can fail you. So you have seen till now the power and potential of AI in security, and it is natural to build a predictor model in AI which can predict and prevent the attack before it happens. But the truth is that AI is not the miracle. In fact, it's the double-edged sword. Okay, which is not handled carefully, then it can lead to poor judgment and even worse. So I want to share with you 3 ways of artificial intelligence can fail you in security. The first is due to inherent weakness in the AI machine learning algorithm and its dependency. The second, due to the abuse against your own AI system by malicious actors. And lastly, due to an attack by a malicious software who themselves leverage AI or use AI. Because if we are using AI, the attackers are also advanced. So AI in attacker toolbox, what are the 3 uses of AI by criminals? Let's see that. So we will now look into this particular slide and see how the AI implementation is abused by the criminals. And so when we see that how artificial intelligence and machine algorithms are empowering the cyber criminal to carry out the security attack with a greater speeds. Okay, so let's review some of the way the AI is coming up as a powerful tool in your attacker toolbox. So attacker is spending weeks and sometimes months collecting data, understanding their target, and then finally executing the attack. There are many tools that attackers are using to automate the common tasks such as scanning the network, discovering the services. 1 minute. So most tasks that require creativity and human intelligence still remain manual. For example, the attackers can't bypass and capture the control present on the web page. In other example, they cannot test and fine tune a malware code. Okay, and so such tasks cannot be automated by traditional programming. So what do? We apply the machine learning. An attacker can also use machine learning to bypass capture control, even crack a password, or furthermore, utilize the data and API offered by the tool, such as virus tool, to test a fully undetectable malware. So the attacker, before attacking a potential target, gathers a lot of information about your system and your security system. So the result is the information about they will find information about your network, applications, employee, and then try to reduce the risk of getting caught. So not only does machine learning enable the attacker to be extremely accurate, but also assist in launching the attack on and making it successful. So for example, in spear phishing, so we have different kinds of phishing. So in a basically what happens is that in a spear fishing, the attacker will identify the way the organization will try to recognize and catch them. Okay, it's a new kind of attack now, and they use advanced deep learning mechanism to syntheticate image, audio, video, and make it so genuine that even it bypass. One more example is deepfake, the deepfake video, where you can just take a picture or a video of somebody and mimic the expression and take his voice and make him say something. It's called synthetic voice. So the attacker can do that. Those kinds of things are happening. Okay, so I end up here because the number of students are very less now. Just give me a few seconds. Okay, students, is there any questions? Because only 2 students are joined. It's not fair because what happens is I think there is some kind of a fest you have. So I understand fully that you are totally into the fest and there's no way you have an interest in attending the sessions like this. So I fully understand. So I'm not going to bother you more with much with your time. So Arinakshi ma'am, I will end up the session now here because only 2 students are only there. Okay.
Yes, ma'am. Yes, ma'am.
Thank you so much, students. Enjoy your fest.
Thank you, ma'am.